Welcome to another problem session. So this one is question number 4 from JEE 2025. I think I happened like 3 months ago to 3 months ago, something like that. I don't know. I don't keep track of it. I just found it. I've been doing these problems for a while. So this paper 1 from 2025, and I've done paper 1 and paper 2 already. Just trying to record it. Okay, so this is Vernier Caliper, and if you know Vernier Caliper, how it works, then it's really simple. But if you don't know, it can be pretty difficult to figure out how it works. But let's look at it. Okay, I'm assuming that you don't know how to use Vernier Caliper. So first thing is this is a main scale and this is the vernier scale. So this is the main, these markings, and these markings are called vernier markings. So what's happening is these vernier markings are used to read between these lines. So for instance, this is a 1 centimeter all the way there. Then this is 1, 2, 3. How many divisions in there? Let's see. 6, 7, 8, 9, 10. So each one of the main scale, each of the division 1 millimeter. One main scale is 1 millimeter. Okay, so if so Vernier will have the instrument will be like this, and Vernier will move on it. So you will put something in here and try to measure it. So right now 0, 0, that means this thing is totally the moving side, and the stationary side is like that. So let's see, over here it's going to be, so you put something in there and this thing will move with it. So it has moved all the way there. So we need to figure out, so this is actually that distance, that's the D. So how do we figure out what D is? Well, you can see that D is already more than 1 millimeter, right? So the D is it's between 1 millimeter in the main scale and 2 millimeter. Well, then here is where the Vernier's beginning is like. So from here onward, let's call this gap that we're interested in, let's call it X. And the distance where there will be some place here that actually lines up with the main. So this is where it lines up with the main. Then we are going to call that Y. So if we can figure out Y, we can figure out X. From this, between 1 and 2 is X plus Y. So X plus Y equals to 1 main scale, which is 1 millimeter. We need X. So if we can figure out Y, if we can figure out X directly, we would be done. But we can't figure out X directly. We have to figure out Y first. And so from there, we can figure out X. So if you look at from this green, Y is how far away is Y? Y is 1 vernier division away. So Y equals to 1 vernier scale division. So we have to figure out how much is this equal to in terms of main scale. We find that over there, comparing the two gives us how to convert Vernier scale to the main scale. All right, so let's do that. So let's see, we have a 1 Vernier scale, mark Vernier scale, 2 Vernier scale, 3 Vernier division, 4 Vernier, 5 Vernier, 6, 7, 8, 9, 10. So it looks like the distance from here to here is 10 Vernier division, 10 Vernier scale division, and that's the same equal to 7 main scale division, 7 main scale division, a main scale division. So you can see and this is equal to 7 millimeter. Each one of them is 1 millimeter. So 1 Vernier scale division, 1 Vernier scale division equals to 7 over 10 millimeter. So this is 7 over 10 millimeter, correct? Okay. So, but x plus y is 1 millimeter. Then x is 1 minus 7 over 10 millimeter. So that's just a 3 over 10 millimeter, which is 0.3 millimeter. So this D is equal to 1 millimeter, because the main scale, I already know 1 millimeter. This is the main scale reading, plus the Vernier reading, and that gave me 0.3 millimeter. So this is 1.3 millimeter. So that's the reading. These are given centimeters, so 1.3 millimeter is 0.13 centimeter, right? So it's going to be this guy. So C is the answer. Hope this was informative to you. You learn how to read Vernier of all kinds of stuff. So sometimes you can make most Verniers, are not like 7 divisions or 10 divisions. Most Verniers, when you go by, so this is a made-up problem, but in the regular world, Vernier will be main scale will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so this will be 1 millimeter. Can be like 1 centimeter. This may be 1 centimeter. And Vernier, if you lay completely blocked, then it goes all the way to 9 instead of going to the 7. So this is what you'll see in the lab. So this will be 10. So it's going to be a little bit less than that. 9, 8, 7, 6, 5. So it's going to be this one, then this will less than 1, 2, 3, 4. So in here, this is a lab Vernier. Usually is like that. So over here you can see 1 Vernier scale 10 Vernier scale divisions equal to 9 millimeters. This distance is the same as that distance, different scales. Equals to 9 main scale divisions, 9 millimeter. So 1 Vernier scale division will be 9 over 10 millimeter. which is 0.9 millimeter. So if you had a, if you kind of like that kind of reading in this kind of vernier, then you'll have a main scale will be if you say vernier was moved all the way there and matched one to his main scale reading over there. If you have just that kind of configuration, but you had this kind of vernier, the main scale reading will still be 1 millimeter, but vernier scale reading will be one vernier scale division. So if you work this out, then y, if you do y, y is the y will be one scale division, which would have been equal to, over here the y was 1. Where did it work out? Here's the y worked out. So 1 vernier scale division, because one of the vernier matched with the one of the main. Then this could be 9/10 millimeter, and that would have meant x would have been 1 minus 0.9 equals 0.1 millimeter, and then d would have meant 1 millimeter plus 0.1 millimeter, 1.1 millimeter. And in that case, the answer that would have meant answer 0.11 centimeter. And so I can see someone not noticing that only 7 of the main is matching with the 10 of the vernier. Someone not noticing this and thinking that we have just a lab scale. And I think this way, this question is a little bit tricky, because they want to see if you know how the main scale reading actually works, this X and Y thing, how it works. And so they try to trick you with 7. But I think, you got to be ready. You not only have to know how to read vernier, but you have to know why the vernier is giving the reading that it's giving. Okay, I hope this X plus Y explanation helps you. Okay, if not, then you can just rewind this and watch this video again to make, I hope that will become crystal clear to you. All right, I'll see you in another video. Bye.